Hello everyone. So this is the fifth lecture of week 2, introduction to Python. So yeah, in the fourth lecture we looked at some of the array operations and matrix operations, and yeah, we also looked at the conditional statements, right. So we will start with loops in this class. Okay. So suppose you want to perform an operation repeatedly. Okay. So that is when you actually use loops. Okay. So suppose you want to print a number, print the numbers from 1 to 100, let us say, okay, one by one. So of course you can write print of 1, print of 2, print of 3 and up to print of 100, okay, but that is a very bad way of doing it, right. So you want to automate it, is not it. So what you do is you use something called as the loops. Okay. So there are two commands that can be used for loops. One is for and the other is while. Okay. So let us see how we use both of these. The syntax for these two are slightly different. Okay. So let us take this wonderful problem of printing numbers from, let us say, 0 to 99. I will tell you why I change this. Okay. So I write for I in range of 100. Okay, let me put 10 because the screen is not very big enough to accommodate 100. Okay. So this prints numbers from 0 to 9. Okay. Right. So yeah, now you should actually ask me what does this statement mean. Okay. So what this statement means is that I am initializing the value of I, okay, to have values in range of 10. Okay. What does range of 10 means? It means numbers starting from 0 to something before 10, which is 9. Okay. So you should ask me now. So yes, suppose I write for I in range of 100, print I, it will print from 0 to 99. Okay. So suppose I change this to, let us say, 7. Okay. So this is going to print numbers from 0 to 6. Okay. As simple as this. So you can see that this actually takes values from 0, starting from 0 to the number before the number given here, 7. Okay. So what should I do if I need to print from 1 instead of 0? Suppose I need to print from 1 to 7, let us say. Okay. Yeah. So if you are sharp enough, you would have told that I will print I plus 1. Okay. Yes, that is correct, you can do so, but my question was, how do you change the value of I from moving from 0 to 6 to moving from 1 to 7. Okay. So you should also give the starting element. Okay. So suppose you write 1 comma 8, that means I starts from 1 and then stops before 8, that means it stops at 7. Okay. So you can see that this prints from 1 to 7. So you can start from any number. So suppose I want to start from -7 and then go until 2. So I should give 3 because it stops before 2. Okay. So yeah, in this case it will prints from -7, -6, -5, -4, -3, -2, -1, 0, 1 and 2. It is 2 because it stops slightly before 3. Okay. Good. And what do you do if you want to move in steps? Suppose you want to move in steps of 3 for example. Okay. So, what does this statement mean? It means that it starts from -7, it ends before 9, that means it ends at 8 and it moves in steps of 3. Okay. So, what this will print is -7, -4, -1, 2, 5 and 8. Yeah. So, yeah. So, this is how you initialize a for statement, and the other thing that you have to notice is that the for statement needs to end with a colon, and yeah, until the for loop ends. Okay, all the routine that you give must be given with an indent. Okay, it is the same as what we saw for if. Okay. So, yeah, I will write down the syntax. It is for I in range of start n plus 1 and step size I will write. Okay. So, by default step size is 1 and by default start is 0. Okay. So, if you want a different start you have to specify it, if you want a different step size than other than 1 you have to specify it as well. Okay. Keep that in mind. And so, here you have to give an indent and then write a routine. Okay. So, when you write a next command here it means that the routine has ended. Okay. So, yeah, that is how you write for, and yeah, you can repeat this for how many ever times, how many ever number of times you want, and initialize I accordingly. That is all is I mean that is how actually you write down a loop. Okay. So, this is yeah, a simple example of how you write a for statement for a for loop. Okay. Now, yeah, let us see how we do a while loop as well. Okay. So, a for loop is actually intended to perform a certain routine many number of times. Okay. So, suppose you want to perform a routine 100 times. Okay. So, you want to sum 100 numbers. Okay. Yeah, or you want to print 100 values. Okay. So, you want to repeat the print operation 100 times, right. So, that is why you are actually using the for statement. So, when do you use a while statement? A while statement is used when you want a stopping criterion. Okay. So, yeah, let me give an example. So, suppose okay, possibly I will write down the code and then tell you what it does. Okay. So, while okay, maybe I will take n as 40,000, okay, and I want to find the logarithm of this particular number with the base 2. Okay. Of course, there is a much simpler command which is np.log2. Okay. So, this is log with respect to base 2. Okay. You can see that it is 15 point something. Okay. So, but the basic method, I mean if you do not know about this log command. Okay. So, what would you do? You would repeatedly divide this by 2, count the number of times this is divided by 2, and you stop when yeah, you reach a number which is less than 1, right. So, I mean by which you can actually find that the log is between log 2 is between 15 and 16. Okay. So, that is exactly what I am going to do. Okay. So, how do I do it? While n greater than 1. Okay. So, you will stop when you get 1 or less, that is what it means. Okay. Okay. So, yeah, I would like to count it. So, let us say I call count equal to 0. So, I just do n equals n by 2 and count equals count plus 1. Okay. Now, if you print count, it will print 16. Yeah. So, if you want to understand what is happening, I will also print n here, so that I mean it is clear of as to what is happening. Okay. Yeah. So, 40,000 I am dividing it by 2, it become 20,000, 10,000, 5,000, 2,500, 1250, 625 and so on. Okay. So, yeah, after the 15th step it is 1.22 and 16th step it becomes less than 1 and the loop stops, right. So, yeah, this is a crude way of finding the log base 2. I mean you can find the log base any number, you just have to divide by that particular number. Okay. So, yeah, what this means is that you the syntax for while is while a condition holds. Okay. You perform a particular routine. When does this come out of that routine? When this particular condition fails. Okay. So, until that condition holds true, the routine keeps on performing. Okay. So, yeah, that is basically what a while command does. Okay. So, you can see that the method how for operates and the method how while operates is different. Okay. So, yeah, you use a for loop when you want to perform the routine for a fixed number of times, and you use while loop when you want to perform the operation repeatedly until certain condition holds true. Okay. So, that is when you perform a while loop and a for loop. You can have nested loops as well. Okay. So, before that please note that while uses the same format as well. So, you have while the statement ends with a colon and the routine needs to have an indent. Okay. So, when the indent completes, then the while command completes. Okay. So, it is the same like if and for. Okay. Keep that in mind as well. Okay. So, we will next go to the nested loops. Nested loops is you can put a loop inside a loop. Okay. So, I will give the classic example of matrix multiplication. Of course, I know that you can do it by an at symbol. Okay. I just told you in a few lectures before. Okay. But since I want to illustrate a nested loop. Okay. So, I am going to do it I mean I am going to take this example, the example of matrix multiplication. Okay. So, let us consider a matrix A of size m cross n. Okay. So, from A11 to AMN. Okay. And let us take a matrix B which is of size n cross p. Okay. So, you should have known that AB is yeah of the size n cross p, sorry, m cross p. Okay. So, I will call it C. Okay. So, C11 to CMP, right. Yeah. So, now how do you find Cij. Cij is found by taking the ith row of A and jth column of B, right. So, it is ai1 b1j plus ai2 b2j plus dot 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 ain bnj, right. So, this is the I mean if you want me to illustrate this further. So, the ith row is ai1 ai2 dot 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 ain, and here the jth column is b1j dot 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 bnj, right. So, ai1 b1j ai2 b2j dot 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 ain bnj. So, I can write this as aik bkj from k equal to 1 to n, right. So, I just have to just to find Cij I have to write down a loop, right. So, that is I mean I will write it as for k in range of n, C of I comma j is a of I comma k into b of k comma j. Okay. So, this is the key step. The others are yeah. So, you have to sum them. So, you have to write it as sorry yeah, I should write it as C of I comma j equal to C of I comma j plus this. So, I keep adding this n times. Okay. So, I get the actual matrix, right. So, of course, I mean so this is only for one value of I comma j. So, I have to run this for all values of I and all values of j, right. So, I will write down the full code, which is not very difficult. So, I will use m and n as we had written it before. Okay. So, I think m is still the same. Let me confirm this. Okay, good. So, I will just write n as m plus I of 3, and of course, m at n should give you the same answer, but here I will write down the code for I in range of 3, since it is a 3 cross 3 matrix, and for j in range of 3, C of I comma j equal to 0 for k in range of 3, C of I comma j equal to C of I comma j plus a of I comma k into b of k comma j. I am sorry. And okay, I will print C. I will also print m at n. Okay. Oh, okay. So, I should have written m and n. I am sorry about that. And yeah. So, since I have not initialized C, it will again create a problem. So, I will initialize it with zeros, that is much simpler, okay, rather than writing this line. Yeah. You can see that C and m in I mean the matrix multiplication of m and n are exactly the same. Every element is exactly the same, right. So, you should have also looked at I mean observed that when I use nested loops, I keep increasing the indent. What does it mean? It means that all of these commands fall within the first loop, all of these commands fall within the second loop and just this command falls within the third loop. So, this happens for 27 times. So, in general, in what I have written here, it would have happened for m into n into p times, right. The upper loop is for running for m times, the second inner loop is running for n times and the third inner loop is running for p times, right. So, yeah, this will actually run for m into n into p times, okay, with m, n and p notations as defined here, okay, instead of yeah. So, there might be a confusion because I have used a different m and n here compared to the m and n here, okay, but I suppose you can, I mean, you understand what I mean, okay. All right. So, this was for I mean, it is just an illustration of how you write down the nested loops, okay. And so, yeah, I will now go ahead with user defined functions, okay. So, what are user defined functions? So, you have seen a lot of commands by now. So, in NumPy you have seen sum, product, mean, median, dot and many more, insert, delete and many more, right. So, these have been defined by certain people and that is why you are actually having those libraries, right. User defined functions are functions that you can define on your own, okay. So, for example, suppose you do not know that np dot sum of a vector actually sums all the elements of a vector, okay, does not matter, you define something called add, okay, as follows. So, I can say add of a vector, okay. So, you have to write def means you are defining the particular function, it is not already there, but you are defining that function, okay. So, when you pass this, what should you do? You should write a for statement for I in range of np dot shape of v and okay. So, yeah, before this you should have defined something called count. So, let us say count is equal to 0 and yeah, now you add count equal to count plus v of I, okay, and finally you have to return the value, return count, okay. So, yeah, I mean I could have written it there straight away, but that is okay. You write def add of v. So, you define again count equal to 0 for I in range of np dot shape of v count equal to count plus v of I return count. Yeah. So, I have just copied what was there. So, now if you let us say define a vector np dot array of let us give something different 3 5 1 9 7, okay, and you write add of v. Oh, I am sorry, I should write this. Yes. So, you can see that 8 9, if you add this 8 plus 1 9 18 25, yes, you got 25, right. So, yeah, this is a definition, I mean the definition that you have on your own. So instead of, so I could have also written NP dot sum of V, okay, but I mean I wrote this to say how you would actually go ahead and define your own function. So, if you see the syntax, that is again simple. It is I mean, so when you write down a function, it is define the name of the function. The name of the function is what you write, okay, and yeah, I mean whatever arguments need to be passed to that particular function, okay, and the routine will be written with an indent, okay. So, whenever the indent completes, that means the user defined function is complete, okay. And finally, you write a return, which means what needs to be returned from the routine back to the main code. So, that is what it means when you write a return statement, okay. So, these are very useful when you actually want to define functions, is not it. So, suppose you want to define a function, let us say e power x, okay. E power x is something very simple, maybe much more complicated than that. Let us say I want to define a function f of x as x into e power x minus x squared plus log x, okay. So, whenever you want to operate with f of x, I mean operate with the function, okay. So, you can actually I mean you define the function with, I mean whatever you want the function to be, okay. So, and I mean if of course finding the values is not an issue. So, you can find what is f of say 1.34689 for example, okay. So, yeah, it gives some number and I mean as on a side note, note that e power x needs to be written as np dot exp of x and natural logarithm should be written as np dot log of x. So, if it is base 10 then it is log 10 and if it is base 2 it is log 2 and no other bases are defined. Do not think that if it is base 4 it is log 4, no, it is only log 2 is there, log is natural log and log 10 is base 10, okay. So, I mean these possibly are things you should know, okay. Now, using this I can actually verify many properties of functions, right. For example, suppose I want to verify whether the function is let us say an even function, okay. So, we know that e power minus x squared, the bell shaped curve is an even function, right. So, how do you verify that it is an even function? Yeah, I mean what we are going to do is we are just going to put some random numbers and check if it is an even function or not, okay. So, yeah, let us say x is some complicated 13.789134, okay. And now I am going to check if f of x equals f of minus x, okay. It is true because this is an even function, right. So, you can also do this by generating a random number, okay. So, the following command generates a random number between 0 and 1, okay, or if I use this rather, okay. So, it generates a random number I mean a Gaussian random number, okay. You can also print x if you want, just to give you a sense of what is happening, Okay. So, x is minus 0.354 whatever, and f of x is actually equal to f of minus x. Okay. So, you can see that this is actually an even function. Okay. And similarly, you can check for odd function, you just have to modify this as f of x equal to minus f of minus x. Okay. So, and now how do you check if a function is convex, for example? Okay. You can check whether f of lambda x plus 1 minus lambda y is less than or equal to lambda f of x plus 1 minus lambda f of y, right. For instance, so yeah, I mean I will give you this particular function, sorry, x into log x. So, you can verify in home that it is actually a convex function. Okay. Log x is concave, but x log x is convex. Okay. So, let us put lambda is equal to half. So, what you want to okay. So, now you need two numbers. So, I will write it as, so this is actually a vector x of 0 and x of 1. So, I want to check if yeah, is less than equals f of x of 0 plus f of x of 1 by 2, right. So, I am just checking the midpoint convexity to be precise. Oh, okay, I am sorry, I should not put negative numbers. So, I will now use random dot rand, which is for uniform in 0 comma 1, I am sorry about that. Yeah. So, you can see that the numbers are 0.46857 and 0.26830. Okay. And with that, I mean you can see that the midpoint convexity holds for x log x. I can do that many more times. Now this is 0.91 and 0.42, that is true as well, and you do this again 0.22 and 0.71, that is correct as well. Do this again 0.519, 0.1649, that is true as well. You can in fact run this for 100 times using, let us say, a while loop. Okay. So, write c equal to 0 while c not equal to 100 or okay. So, I will define b not equal to false. So, I will also write b as false. Okay. Yeah. Now, instead of printing it 100 times, I will write this as b, sorry. Yeah. So, oh, I am sorry, I missed the colon and it correctly shows that. Okay. Yeah. Okay, it has to run 100 times. So, it will take a little bit of time. And when it is running, I will just illustrate what I have done. Oh, okay. This is okay. I have not given c equal to c plus 1. That is a mistake on my part. Yeah. Oh my god, that is a mistake again. Yes. Yeah. Okay. So, now what I am doing is I am repeating this for I mean 100 different randomly generated values. Okay. So, how I am doing it? I am so you can see that I have initialized c to be 0 and b to be true, and this loop will run either until C becomes 0 or B becomes false. Okay. So, it will go in only if C is not 100 and B is not false. So, if B is false, it would have come out. Okay. And or yeah, if C is 100, it comes out. So, you can see that I will run this again. Yeah. So, yeah, I have run this for 100 times and yeah. So, for all 100 times it has given true. Okay. So, yeah, so you have kind of verified that this number whatever this function whatever you have written here is actually a midpoint convex function for 100 different pairs of values. Okay. So, fine, this is the user defined functions. Okay. So, we have seen quite a bit of Python in this week. We started with print statements, assignment operations, then we moved on to different kinds of array operations, matrix operations, and in the last 2 lectures we learned conditional statements, loops, and finally we have finished with user defined functions. Okay. In the next week we will start with the optimization algorithms. Thank you.